Hello, everyone. This is Dr. Lennon, and this is the final exam review. So these will be topics similar to the ones we'll see on the final exam. And just a reminder, if you ever have a question that doesn't have an option to open the data in StatCrunch, you can always get that by going to the My Math Lab Mastery, clicking StatCrunch, and then opening it externally. So you go to the StatCrunch website, as we've demonstrated several times, and click Open StatCrunch, and StatCrunch will be there for you. However, for this first question, do I need to open that again? Maybe so. Yeah. So let's go back to homework and final exam review. So this first question is a 5-number summary type question, trying to find the mean, median, and mode. And the best way to do that is open the data in StatCrunch and go to Stat, Summary Stats, select by column, and then you have a lot of options for what you want to do there. Default has pretty much everything you need. If you click Compute, you see the mean, the median, the range, min, max, Q1, and Q3. So that should help you answer any of the questions you need here. I think there's 3 parts. Let's just enter the median. So I guess I shut down StatCrunch by mistake again. So again, stat, summary stat by column, variable 1, the median was 45. And then the quartiles, Q1 and Q3 and so on. So let's continue. So the next one is the 68, 95, 99.7 rule. So again, we know in between the middle two, we have 68, 95, 99.7. So to figure out the tick marks, you can either do that by taking 100 and just adding multiples of 11, which is probably the easiest way. So 100 should be your middle number. So that's either A or C. In this case, it turns out to be A. So if it asks what interval you'd expect the central 99.7% to be on, you would go 3 below 67 to 3 above 133, and similar for other types of questions. So that's a pretty typical normal model type problem. And then, okay, what percentage of people have a score above 133? Remember, we broke them down into 4 parts. So you have the 34% part, the 12.5% part, the 2.35% part, and the 0.15% part. So above 133 is the smallest. That is 0.15%. So 89 and 100, you play the same game there. All right. So number 3. So I'd done some of these before in class, so the answers are already filled in. Let's go ahead and just put in something incorrect so we can start the question over. All right, so for these, it's going to show you how to do it by hand if you look at the question help on the final review, but the easier way to do it is to just use the binomial calculator. So, I wish there were a way to just do similar question immediately. Okay, so let's go back to that one and do a similar question. So similar question. So find the probability that the first lefty is the 4th person chosen. So 5 people are selected at random. So again, we're going to be using StatCrunch here. So what we want to do is we want to go to a particular calculator, and notice this is a binomial model because we have success failure with independent trials. So we go to stat, calculator, binomial. So this question is saying, all right, so n is equal to 5 because we have 5 trials, and we have 0.14 as the percentage of people that are left-handed. So if we select the 5 people at random, and we're trying to find the probability that the first lefty is the 4th person chosen. So for this particular part, you don't really even need the binomial calculator yet. What you're trying to do is just figure out that the first person that's left-handed is the 4th person chosen. So that means you're looking at each trial independently. So your first 3 trials would each be 0.86 because you're going to pick a right-handed person, a right-handed person, a right-handed person, then a left-handed person. So you would enter 0.86 to the 3rd power, and then multiply that by 0.14. And that gives you 0.0890. If you enter that in your calculator. So just so you can see what I did on that previous example, I opened a scientific calculator. So that's 0.86 to the 3rd power times 0.14. So let's go back to the question. So for B, we want to find the probability that there are some lefties among the 5 people. So we can use the binomial calculator for that. So stat crunch. Here we want to just, if there's some lefties, that's going to be the probability that's greater than or equal to 1. And you can click compute. So it's going to be 0.5296 if you round to 4 decimal places. All right, find the probability that the first lefty is the 2nd or the 3rd person. So that would be like part A, and you just add the 2 together. So the probability that the first lefty is the 2nd person. Let's go back to the calculator. So the first lefty is the 2nd person would be, well, a right-handed person and a left-handed person. 0.86 times 0.14. We don't care what happens after that. We're just trying to make sure the first lefty is the 2nd. And then if it's the 3rd, it would be 0.86 times 0.86, 0.86 squared, times 0.14. So you get 0.2239. .2239. And for exactly 2 lefties, again, we'd go back to the normal calculator, and we just set that equal to exactly 2. And we can compute that there. So 0.1247. And, similar. So we've seen some of these on the homework before. So. Okay, so for this example, again, what we're doing is we're trying to find the residual. They give us the equation of the line. So basically, you have the weight equals negative 0.571 plus 0.1939 times the length. So we have the actual data, and remember what the observed is. It's or the residual. The residual is the observed value minus the expected value. So what would the model predict? Well, the model would predict based on the it would predict the weight based on the 48 centimeters in length. So we could figure out that number on the calculator by doing let's say negative 0.571 wrong one. 0.571 plus 0.1939 times the length. Point 1939 times the length. There's a plus 0.1939 times the length, and I believe the length was 48. So go back one more time. Negative 0.571 times, this. So they're saying the residual. So he weighed 3 kilograms, and we're trying to figure out, oh, it's 5.71. I think I did something different there. So let's go back to the calculator. I did 0.571, so negative 5.71. There you go. So that is that's the actual value right there, or that's the predicted value. So now we need to do predicted minus observed. So the observed was 3 minus the predicted, which was this previous answer. So you can click this answer button, and that's standing for that. It gives you the negative 5.97, which is, I believe, what the answer was. Yeah, negative 0.597. So that's how you can get that. What does it say about them? Well, I think that's pretty straightforward to interpret. So the observed minus the expected, it's basically telling you that the predicted model expected more for the weight. So select the correct choice below. Okay, just briefly reset the question so we could work on it again. So let's open up this data in StatCrunch. Typically the easiest way to do it. So we're trying to find the regression model. The regression model can be found by going to Stat, Regression, and then we're doing a simple linear regression. The X variable is the capacity, and the Y variable is the price. So click Compute, and we see that the intercept, which is B1 is, or excuse me, I think B1 is the slope estimate, negative 142.22, or positive 142.22. All right, so we get that value. And then what does the slope indicate? Well, it's indicating the change in Y over the change in X. So our Y is our dollars and our X is our input. So it's basically saying for each additional terabyte, it's going to cost you 142 extra dollars. So it indicates the additional price for each additional terabyte. So units of Y over units of X. Find the intercept. Well, we've already got that. Just go back to the data. So it's negative 298.16. All right, and because it doesn't really make sense in the context of paying for 0 terabytes, it really shouldn't be interpreted. So it's indicating the price for a hard drive with no capacity. All right. Writing down the equation is essentially just the same as before, but you have everything you need to interpret the last things. But okay, let's do one more part. So minus 298.16 and then 142.22, I believe. All right. So what would you predict for the price of a 20 terabyte disk? So that is the value when you plug in 20 for X. So you can actually go back to options, edit, and add a predicted value. So the predicted value, where is it? Prediction of Y when X is 20. We can do that right here. Click Compute, and we get a predicted value at the bottom here. So it's predicting Y is going to be 2,546.21. All right, so this last one, it says you found a 20 terabyte for $25.70. According to the models, this is a good buy. It's actually not a good buy because the predicted value is lower. So the actual price is predicted more than the predicted price. So not a good buy. Anyway, this is similar to the homework, and I will get back and we'll start with question 6, the last half, in part 2 of the review. Thanks.